Right, question 5 part B. The waist tip ratio for men is distributed normally with mean 0.89 and a standard deviation of 0.071. And the top 20% of men are regarded as having a high waist tip ratio. Calculate the smallest waist tip ratio for these men. Now, the first thing with a question like this is to actually try and get this information onto a normal curve. So here's one that I did earlier. You can see that I've illustrated the top 20% of men as the sort of highest 20% of the curve there. And that, of course, means that the rest of it, the other side, must be 80%. And we do need that number because when we're going to use the normal tables in a minute, they only work with the larger percentage. So you always need to work out if they give you the smaller tail end, take it away from 100% to get the other side of it. I pop the mean in the middle, and this is what we've got to find here, x, which is the actual waist tip ratio, that sort of divides the top 20% from the lower 80%. Now, in order to do that, we need to look up our 80% or 0.80 on the tables to get our Z value. So here are the normal tables down there. And looking up 0.80, you can see that we've got this value here of 0.8416. When we're using probability to work out a Z value, it's this little set of normal tables that we use, not the main ones. Now for the calculations, back to our curve. What we do is we do the usual process of standardization. So we say our x value, which we don't yet know, minus the mean over the standard deviation must be equal to the value that we get from the tables. So there's our little equation there that we're going to use. Then we just rearrange it step by step. So first of all, times the right-hand side by the 0.071 that was in the denominator. Next step is to add on the 0.89, and then you just do that on your calculator, and you get the 0.95. So that is the waist tip ratio that divides the lower 80% of men and the upper 20% of men.